Stop guessing at how to configure your environments. You can build a completely autonomous, zero manual input orchestration engine. We are going to construct a strict, closed-loop pipeline from scratch, and we will do it in under 2 hours. To start, you need active environments for Notion, N8N, and Make.com. You will also need your API keys ready for Claude 3.5 Sonnet, X, and LinkedIn. This diagram outlines our exact architecture. We initiate with a single starting node, branch into a central AI processing agent, split the data to our 2 social platforms, and loop the confirmation data straight back to the origin. By linking a persistent memory database directly to multi-platform APIs, we bypass the need for manual copying and pasting entirely. Step 1 is establishing the starting environment. We will use a strictly localized Notion database as the system's singular origin point. This mockup demonstrates our exact trigger mechanism. By mapping a property change in Notion, moving the status from draft to approved, we immediately fire a webhook. Inside this terminal window, you can see the actual data structure generated by that status change. This JSON payload contains the raw topic idea to publish. The webhook then routes the data out of the origin database directly into your N8N receiver environment. Watch your mapping closely here. The primary failure point is a webhook payload mismatch between the Notion output and N8N receiver. Successfully catching the approved payload inside the N8N terminal confirms your trigger system is fully operational. Now we move into the central AI processing environment, where N8N ingests that raw database text. Add an advanced AI agent node in your N8N workflow and securely connect it to the Claude 3.5 Sonnet API. You must calculate strict system prompt parameters here. If you send unstructured text to social platforms, their APIs reject the payload. This node displays the exact parameter required for our first output. You must define a strict 280-character maximum so the copy correctly formats for X. We then run a parallel logic process for our second output, taking that exact core idea and optimizing it for LinkedIn. On this split-screen UI, notice the contrast. LinkedIn instructions require structured line breaks and metadata hashtags, creating a professional, long-form post alongside the short-form copy. Defining these separate parameters in your system prompt is a mandatory mitigation step. It actively prevents character limit overflow errors during the final upload process. By locking in these distinct constraints, you guarantee the AI consistently outputs technically perfect, platform-ready copy every time the webhook fires. Once generated, N8N sends a localized HTTP request to push the finalized copy into Make.com. This diagram illustrates Make.com routing, splitting data into 2 pathways. Path A connects to the X API, executing the short-form post instantly. Path B connects to the LinkedIn API, holding the professional post in a queue for peak hours. Check your data mapping. You must ensure the 280-character payload generated earlier is mapped exclusively to router path A, or both posts will fail. Architecting these partition pipelines ensures your content adopts the proper formatting and reaches the intended audience at the mathematically optimal time. The final technical phase is securely closing the automation loop. To trigger the confirmation loop, configure Make.com to listen for an HTTP 200 success status code from both the X and LinkedIn APIs. This terminal mockup shows the resulting action, an HTTP put request containing specific headers and tokens sent from Make.com straight back to your origin database. This request automatically handles the remaining manual steps. It flips the status to published. It injects the live web URLs. The database maintains its own records. You completely eliminate the need for manual progress tracking. Execute a final, comprehensive system test run to observe this entire closed-loop architecture working perfectly in real time. You enter a raw text idea. You approve it. The AI processes it, the router partitions it, and the APIs publish it, with 0 manual input required from you. Back in your database, this final verification view confirms the cycle is complete. A green publish tag and live hyperlinks are ready for tracking. Your orchestration engine is now fully deployed. Verify your environment logs to ensure the routing remains smooth, and let the entire automated system run. Start building your own automation engine today. Drop your specific setup parameters or custom prompt constraints in the comments below so we can see how you optimize the pipeline.